Hi folks, welcome to the Break Key. My name's Henry, and today we're going back to the Forth ROM. We have a nearly feature complete immediate mode set of words. Well, I mean, as feature completed as it needs to be to do the basic things that, a computer language is going to need to do. But the one thing we don't have is the ability to actually write programs, which is to say, to compile programs. So for that, we need compile mode. Now, as I started working on the process for this, I found a few things that I'd made mistakes on. Of course, it's Henry. What else would it? Of course, it's the break key. What else would you expect? And I found some corrections that I need to make and some changes that we're going to need to make. There's going to be a dive, as usual, into a little bit of refactoring, a little bit of implementation, and hopefully a lot of fun as we dive into Forth compilation mode right here on the break key. And first, for some quality of life. It's nice to know what words are actually in the dictionary, so let's put that in there. Now, in the standard, words is shown as being, it's there. It lists the definition name, the first word list of the search order, but it's not shown as being in the core grouping of words. That's fine. I'm not going to worry about it not being in the core. It's a nice quality of life thing to have. Let's get that in there then, shall we? I'll pause here for a minute. This is something that I discovered when I was working out the process we're going to go through. So, Control F, and I've got that set for... When we throw this out into, let's see, translate your character to VGDSCII and put it on the screen. Next character, please. We don't take time to notice whether or not we need to actually scroll. And if I have a sufficiently long enough string, then type is going to extend beyond the 132 character line of text that I've allowed as a scrollable buffer. So realistically speaking, if I'm to modify type, I should modify it such that it does a scroll check every 32 characters. Let me mark that in here just as a thing for later. Scroll check does look at the Y register, so let's review what scroll check actually does real quick. Gets the cursor off the bottom of the screen. We compare Y. It expects the current cursor location in Y. It returns the new current cursor location in Y. It doesn't care which cursor it is, it's only using Y. In our case, we are using the print cursor or the output cursor. There we go. Earlier on, we pushed X, which is to say the dictionary entry that we're looking at. So in this particular case, our first iteration through, it's the first word defined, the word or dictop, the location at dictop, the location in memory where the first dictionary word is. We push that onto the stack. So we've got that location on the stack. We then load X with the value that location points to. And remember, the first element, the first 16 bits of any definition is a pointer to the next word in the list of definitions. So by loading X with the value pointed to, the value contained within this is an indirect load, we determine whether or not we have another dictionary entry, because the last entry in our dictionary, which is, let's see, it's depth in this case, has a link field address of 0 indicating the end of the list. That should just work. Let's find out. I type in words, of course, words and you'll see that as expected, it is traversing in the order that exists in the dictionary. But now we have a list of words. If I do this again, it scrolls properly. Good. It's scrolling properly. It's doing exactly what it needs to do. Lovely. Things are correct. Nice. Now, as I was perusing the standard, I found something that I've been doing wrong. And that is, let's see, I want to go over here. I need to go to my table of contents, and I want to go to terms. And that was the concept of an immediate word. And that hit me as I was reviewing the words that we'd have to put in here. So let me look at what immediate means. Okay, so an immediate word is a fourth word whose compilation semantics are to perform its execution semantics. So the default compilation semantics for something like, say, multiply. And under default conditions, this very semantic is what would be compiled into. This would become the runtime semantics in the compilation. The default idea of compiling a word being, if a word just does something, when you compile it, the new definition has that execution context, that what it does, appended to the runtime. That is to say, all right, if I put star into a compiled word, it's not going to multiply what's on the stack immediately. It's going to compile in, multiply the items that are on the stack when it gets there, when it's run. The two are a little bit different. I'll look at it like this. Let's go back to the standard, to the core, and let's look at a word that we'll use to escape out of, which I can't seem to find in this list. There we go. That's what I'm looking for. This word only operates in compile mode, but it performs the execution semantics given below, and it has no runtime semantics. That is to say, it doesn't do anything in the program it's compiling. It only affects the system while compilation is taking place. Perform the execution semantics given below. Enter interpretation state. It's an immediate word. So it only works in compile state, but it works immediately in compile state. This becomes important because I've been marking all of our interpretation state words, and I guess I'll change my nomenclature now. Instead of saying immediate mode, I'll say interpretation state. I've been defining all of our interpretation state words as immediate mode, and that is incorrect. In the definition fields that we're using, I've gone with the Arduino Forth idea, or the Flash Forth idea. And here we have the flags that we've been using. I've been using immediate, inline, and compile only. So I've set this bit, which is 8, and this bit, which is 4 for immediate. Currently, I don't have any immediate words in the dictionary. I only have words in the dictionary. I don't think I have any immediate words in the dictionary. I'll have to double check to be sure, but I don't think I have any immediate words in the dictionary. None of these need to be marked as immediate. Some of them do need to be marked as compile only, and compile only will have separate execution semantics and runtime semantics, whereas immediate words will only have execution semantics. So I need this flag, this immediate flag, and I need it available. I need to go and fix things. Let me check to see what's going on with search. I think search dict is what does the dispatch. I'm not really sure. All right, so I'm explicitly checking the immediate bit. So I want to change this so that we're not checking the immediate bit. That check still needs to be there right now, but I want to make sure that it is not a compile mode thing. Let's see. Oh, right, because that's the A. Oh, shoot. I got that all wrong. So I need to fix that real darn quick because that was that. Yeah, wrong bit. Okay. Now we need to fix this. I don't want to worry about that. I want to see if we have the compile bit. So that's going to be 10. Bit B, 2, X, and let's see. Lovely, that worked, and good. Lovely. All right, that's working. So I haven't broken anything yet. This is good. The first fix is in. We have switched it out so that we're not using the immediate bit incorrectly in the dictionary definitions. This is going to be important later when we do have to define words that are immediate according to the standard. All right. Let's go back to the top of the dictionary now, and let's see. We've got the definitions fixed. Now, in order for us to tell the difference of whether we're in interpretation state or whether we're in compile state, we do need a flag, and we need the ability to poll that flag. So I need to cell containing the compilation state flag. It is true when in compilation state, false otherwise. The true values in state is non-zero, but is otherwise implementation defined. Only the following standard words alter the value in state. So state needs to be a read only, but it drops an address. So when it drops this address, only the following standard words alter the value in state, : semicolon, abort, quit, : no name, left bracket, right bracket. A program shall not directly alter the contents of state. So this needs to be a protected address or a mirror address in order for it to be effectively read only. Let's put that in there. Now, the only thing I can see that's going to be problematic is that this will only be modified. The way that I'm thinking, it's only going to be modified when state is called. I don't see a reason to okay, it's backward compatibility, and I don't see where it's going to be useful outside of just pulling that data. But this is the standard, so I'm wanting to implement the standard. And it's recalling an FF. That makes no sense. Oh, that's right. I forgot to initialize it because we start out in interpretation state. That looks better. So now that I know what the state is, we're going to need to do some refactoring. We've got some changes that need to happen because we're moving into compilation mode. Everything as far as execution, dispatch, that entire loop is handled here in searchdict. And there's some refactoring and some splitting up we're going to need to do. This encompasses the function of a few words. The first word that it encompasses the function of is, more appropriately, find, I'll say. Now, find is not necessarily lower level from, but let's see. If we go to the search and we go to tick. Some of us may be already, well, some of us may already be familiar with tick. Tick gives us an execution token for any particular definition. An ambiguous if name is not found when interpreting tick XYZ execute is equivalent to XYZ. So tick just gives us the raw execution token. Find, on the other hand, handles things a little bit differently. Instead of being provided a name directly, tick takes a counted string address and then utilizes that. So we'll implement this. And it also gives us, when it returns, it gives us a bunch of potential error conditions. So let's see. The address here is 0, so that would be find the definition. Okay. If the definition is not found, return C address and 0. So this remains the same, and we wind up with a flag that's a 0. If the definition is found, its execution return its execution token XT. Great. If the definition is immediate, also return 1. Otherwise, also return -1. I need to do a little bit of thinking on this because I had at first blush when I was looking at this, I was thinking, oh, well, here's an easy way to tell between a compile mode word and a non-compile mode word. This doesn't say if it's immediate. Let me do this. Let me start up Forth. Wait, what? Oh, I need a counted address. Right. Okay, that's right. Here's how I will interpret this. I can't see a viable distinction between what is compile only and what is immediate, so I'll treat the two as being effectively, for the purposes of what find is going to give me, I'm going to treat any compile only word as also having immediate semantics, and the immediate words that I've got defined now that are immediate, or the immediate words that I'm looking at, are compile only words. So that's what we're going to do. Let's get back up here and set up our word. So what is it expecting? It expects the end of token locate. Oh, no. I need a countable address. We'll worry about the rest of that later, but I need a countable address first. So here's how we'll implement the execution token. The execution token is the address that we will jump to start this code going. Can I clobber Y at this point? I'm pretty sure that since we found it, I can clobber Y. Yeah, because Y contained the address of the. Yeah, we've already gotten that. We don't need the search term anymore because we found it. So I can clobber Y pretty safely. I've still got something sitting on the stack over here, don't I? Yeah, I still got that sitting on the stack, so I actually need to pull that off, drop that off the stack as well. At this point, I need to test to see whether it's immediate or not. Okay. Okay, so clear D it doesn't like. I'll have to fix that. That should take care of it. Let's check that. Good. Now in this particular case, I do want to run the. Let's just see if it actually works. Oops. It helps if I use something that. There we go. First things first. All right, find is there. It's in the words. So let's see if we can find. And it's not happy. Why does this not surprise me? All right, we got to step through this. So let's do a debug and let's see if we can't figure out what's going on here. B0053 gives me a pulse Y, and I've only pushed the one item there. So there's my problem. And if I remember how I was writing this, this was part of that failure mode, or this is part of the, we've failed to match the search term, and I needed to clean this up here as well. So instead of a pulse Y, we'll do a pulse B. What do I have that's going to mess with that? Okay, so at this point, we need to save the start byte of the search term. So that's where that push S happens. So what I will do then is I will add this in. All I've done here is changed it out so that I know that I'm only going to be pulling B. If I haven't found a length match, I'm going to need to pull Y if I have found a length match. Let's see if that fixes our problem. Let's just send it. And it still locks up. So there's still some kind of stack wonkiness happening. We were fine all the way there, so let's make sure that we're not jacking up our stack too bad. So step through here, everything was fine until we got to, all right. I went too far. But let's see what the stack register says. Stack says 00E6. 00E6 contains A3EA, and A3EA in our listing is, let's see, restore the word clobbered registers at the end and end of token location, clear any error conditions, and go home, which we were in. We were in search dict. Okay, so this was in the process where we found it. That's going to simply return us back to the interpretation loop. All right, so we're now at B057. Get the next dictionary entry. Let's see, and load AX. X contains B064. And do we have a zero flag? We do not have a zero flag. And then we just branch back to B027. B027 is... What's in Y at this point? Y still contains 301. Okay, so we're fine. Why am I branching always back to B027? That's a problem. Okay, I branched back to the wrong place. Okay, because that should not be branching back to... If we're here, the search has failed. If we're here, failed to match search term with current dictionary word. We don't want to branch back to 3B because that's just here. I want to, okay, I want to come all the way back to 1. I don't think I even need 3 here. I think I just need to come back to 1. Let's see. Yeah, because I need to start the search sequence all over again. And if I've gotten this far, I need to do that. So instead of being branched, we'll branch to 1 back. Let's see if that fixes it. And it's still not happy, so that's good to know. Oh, okay. No, I don't need to clean up. Okay, yeah. Here's a mistake. Okay. I actually don't need to pulse B. I need that to stay where it is while we're still searching. The only thing that might be problematic is I need to pull SY, because that may need to be cleaned up from the stack. Let's try this again, and let's see if that fixed it, which it may or may not have. Still not happy. B is now 00E5, should be my stack pointer. Yep, 00E5. And the value at 00E5 is 5. Good. B is now going to be loaded. Where am I at? B01B. All right. According to this, that is grab the name field header byte, which contains an 84. We mask that off. It becomes a 04. We compare that with the value at the top of the stack, which is a 05, and that comes up with a carry. So that's, or it comes out non-zero. So that branch not equal will happen. We'll go to B055. Let me try saving it and then recompiling it. Maybe that'll help. Okay, yeah, there we go. Actually, yeah, let's just quit this and send it and see if it works before we go into the debugging. It didn't work. That is a problem. So something's going wrong there. That looks like an interrupt got messed up. I'll run this and see what it's doing. It's not coming back to the sync, and the stack... Those have not been reset, so we're still fine there. All right. Let's see what got borked. That looks like something got borked in the return stack. Stack is at 00E5. 00E5 contains 5, which we expect right there. What a B0 is doing there, I'm not entirely sure. Oh, no, that was there before, I think. I'm not sure. Let's see, we got the and B0F, which, yep, that takes care of that. It's going to be a BNE. We're going to come back over here. And at this point, we're going to load XX, which is going to get us to the next word, which is B0062, or B062. And B062 is state, which is the second word in the dictionary. And that's fine. So that works. It's not going to be equal, so we should skip to B05B. We don't skip to B05B. And then now, what's my stack pointer at? My stack pointer is still at 00E5. 00E5 is 6, 7. Yep, it is still correct. Everything is still correct. We come back here. We've got that correct. And B0F, we compare BS. And in this case, I should go into, and it's a BNE B055, but it's not going to be an E because everything's correct. So we load A with 03, and we're going to push Y on the stack. What am I saving to B025? We need to save the start byte of the search term. Y currently contains 301. Yep, all right, so I need that value. Load B with Y plus. B contains... That doesn't look right. A 77 does not look right. No. Hex 77 is correct. What, Oh, dag nabbit. Okay. That's converted into ASCII. I think. Let me find a handy dandy ASCII table somewhere. Yep, it's lowercase, all right. Well, that changes the logic quite a bit. But that actually shouldn't be too bad because I can take that value and I've got, what do I have here? Expects the character to be translated in B. Good. All right, so now and it's still doing that. So it's failing somewhere. I'll bet that's pulsing Y again. Yup. All right. What I get for not following the logic the whole time. All right, so that doesn't need to be a branch to 4. That needs to branch to 2, and we'll change this. We'll get rid of this entirely, and that'll take care of that. Save that. Now, no, I don't want to make rack and ruin. Let's see what we've got here. I fixed it. So let's see what the stack looks like. Oh, shoot. Did I drop the execution token? It doesn't look like I did. Let me make sure that... Drop the search term address. Get rid of the search term byte count and search start byte. Put the found execution address in Y and push it onto the parameter stack. Did I already do a pull? Yes, I did. Okay. Get the search string. I already did that. A pull UY. That's already pulled. So this doesn't need to be removed. And the rest of this is assuming that that already exists on the stack. So I don't actually want to do... So I want to do a load Y, comma, U here. Get the search string address because that will probably do it. So let's see if that fixed it. Words is at B07D, and according to my listing, that's not right. There's something wrong here. So B040, if we're here, we found the word. A should contain the offset to our execution address. What do I have in X and what do I have in A? X contains B077. B077 should be, yep, there it is. B077 is, in fact, where our words begins. And that A should contain, oh, wait a minute. I see what happened. Maybe I don't see what happened. I have 2 bytes there and 1 byte there, so that should be 3. What does A contain? A contains 6. How does A only contain 6? Where did I mess up A? Wait, whoa, what just happened here? Oh, there's, okay, that, now it makes sense. Let's try this again. So it looks like what happened is I pushed Y, and then when I wanted to restore the token length, I didn't think about the fact that I pushed the first character location in there. So this actually needs to be 2, S. That should do it. -1 B07F. All right, lovely. Yes, B07F is exactly where it lives. That's beautiful. So let's do that again. It does find it, -1 B1E7. Oh, shoot. Uh-oh, something's wrong. That should be a 1. That should not be a -1. Oh, there's my problem. I was not thinking when I wrote that. So here we have comma U. At this point, I don't even have. Right, so it's not even looking at the right place. Let's see, get rid of the search term byte count and search term start byte. Put the found execution address in Y and push it on the parameter stack. At this point, X still contains, there we go. I think that'll fix it. Because instead of looking, because X still contains our original dictionary address. Oh, now it's not happy at all. Hang on, what the heck happened here? That looks a little weird. So that should actually, yes, we don't have to do any flipping. No, so we don't have to change that. Let's go home now. All right, cool. And it, because otherwise it would have skipped over here, cleared A, cleared B. No, I already did that. I don't need to do that anymore. Okay, yeah. Now you make, okay. That should fix it. That should fix it. Because, all right. Thought process. I'm really bad about this. I'm just going to, yeah, that should fix it. All right, okay. So what I did have is I didn't have this here, and this was, let's do this. I didn't have that local there. So when it found something, it was comparing it against, it would load B with 50, it would bit B with the value in U, and at this point, U only has a 1, and U has the value 1, so of course this would come out 0. it wouldn't branch if not equal to. So it would stay 1 in there. It would negate that value, and then it would return. It never went there. When I changed this to X, all of a sudden it made a valid comparison, and then it branched back down to, instead of coming to the RTS where it needed to be, it would branch down here to the other exclamation point. And that caused it to do a clear A, clear B, push U, pulse, and that jacked up the return stack. So all I need to do is put a local thing there, and that should work. B07F, and if I look at B07F, that is the execution location for that. And it's a 1. A 1 indicates that it is, if the definition is an immediate, also return 1, otherwise return -1. So what happens? That also returns a 1. All right, we're at B048, and at B048, we're only in here if we found it, so we did find it. X points to B077, which is the starting location, or the dictionary location for words. All right, and let's start looking at what B048 does. So we'll start by assuming the word we found is immediate or compile only. So at that point, B contains 1. Now, at this point, U is 7FFE, and on the user on the stack is B07F. B07F is the found location. That's fine. And then we push a 1 onto the stack. That says that it's immediate. Now, I load B with 50, X, and comma X, B077 contains 4, 5, 6, 7, B0, 36, 10, 39, oh, okay, B077. I see what I did wrong. All right, that's what I did wrong. I neglected to put in the offset for the actual byte, because the first 2 bytes are the link field where the next word is. The next byte is actually the name descriptor. Perfect. That's doing exactly what I wanted to do. That took a lot longer than I expected. Ugh, that was annoying. Okay. We've already found it. So the next thing that needs to be done after find is, let's see, going to be a word that we call execute. So execute is going to be very simple. He says with bated breath, remove XT from the stack and perform the semantics identify it. Other stack effects are due to the word executed. So in this particular case, execute is not going to use that extra flag bit that was there. So I'll need to remember to drop it before I run it. But what we get is an execution token. Now, I've already decided that the execution token is going to be nothing more than the jump to address. Easy enough to do. So if I am thinking correctly, what I should be able to do is ridiculously simple. This should work. It should work so ridiculously well because all I need to do is jump to it. This doesn't return. It simply transfers control. There we go. So let me save that. Let me make a symbol real quick just to make sure that nothing went awry. Okay, everything looks good. And back up here towards B1000. Good. We've got execute and everything looks fine. Pull U PC, it's happy with that. Got 4 items on the stack, so I need to drop 1. And now I need to execute. Okay. I've only got 1 item on the stack, which is an 8. Nice. Very, very nice. Now, here's the trick. Execute will not care if the execution token that I've been given is... It won't care if it's an immediate mode value or not. It honestly, it just will not care. It won't worry about it. I'm looking at this as a low level, very low level word. Good, good. That means that I should be able to replace this entire loop. But I need to adjust something with the token buffer here. Where is the token buffer? Token buffer, token buffer, token buffer. And that'll be helpful because I speed this to find and everything's going and it's just going to work. All right. So at this point, that should completely bypass everything. Dispatch processing of the token, and we're just doing this in interpreter mode. So let's quit that. Let's do the make and it assembled, no problem. And let's see what we have. Oh, that's weird. Well, that'll do it. I don't want to load into Y what's at 210. I want to load into Y the value hex 210, i.e. the address itself. This, an immediate. It needs to be an immediate. Urgent, but not immediate. All right, now you're giving me that problem. It's not falling through to find the numbers. We're A2EE, which is at the bottom of I find, so we should see something if we look at S7FFC. So 7FFC, C, D, E, F, that is correct, contains a 0 and then 210. All right, it was not found, 210 is still there. So now we pull U that, okay, we hit the pull UD, which is exactly what we want to do. We want to test B. We come up with a 0 and we branch if not equal to a, let's see, and so we should 0 means that it wasn't found. If it wasn't found, drop the token C address. U now contains 8,000. And now I go on to procnum. Since that's a BSR, there's, RTS, return. Let's see if that fixes it. But now procnum also gives me, let's see, does procnum handle the error or what? Hopefully that'll do it. Let's see if that worked. Again, urgent but not immediate. It did not do it. It did not do what I wanted to do. Try as a number. Where'd I put you? You're Proclin. There we are. Procto. Try as a number and go home, which means go there. There we go. That'll clean up the stack. Oh, it doesn't like it. Let's see, 8-bit relative error, and that is at line 452. So line 452. Right, that should fix it. That's happier. All right, good. What's on the stack? Lovely. That's working. And if I put F in there, I don't know what that means. Good. X. What? What do you mean you don't know what hex means? VGDSCII to ASCII strikes me again. Well, at least I know what the problem is, and I know roughly how I need to fix it, so let's get that worked out. Find is expecting ASCII. I think what I'm going to need to do is just translate everything that's coming in into ASCII at some point, but for right now, I'm just going to leave it VGDSCII and I'll leave this hack in place. All right, that should take care of it. Y, not load effective address of Y. Load Y. Now let's try it. Lovely. Good. Yep, that's the execution token. That's correct. All right, problem solved. Hacky, I don't like it, but the problem is solved, and now it's kind of sort of doing what I thought it would be doing. All right, let's get out of here, come back over here. So find is working. We've got execute is working. And I know that execute is working because I actually executed it. I ran depth and everything still seemed to be functioning fine. Good. So now I want to make sure that the modes are going to work, whether we're in compile mode or whether we're in interpretation mode. That becomes important here where we get the print the O, where we do the print the OK. And I want that to be different based upon, let's see, whether we're in compile mode or not. That should work. Let's run that. All right, so that appears to be working. The next step is going to be getting into and out of compile mode. And those will be enter interpretation state. It's an immediate word and it's only effective in compile mode. So I want to go to the one that enters into compilation state. That I tested it in G4. I can do that from the interpreter. So it doesn't look like I can enter that character. I'm going to need to fix that. Okay, so shifted arrows are going to do something completely different than non-shifted arrows. Looks good. Mine there. Nice. All right, that looks exactly like what I wanted to say. So I believe, okay, you don't know what that means. SCB 80. Oh, that's my problem. Okay. Because I didn't do the count right. So let's get out of here, come back over here, set this to have the correct length, and see what happens. if this happens right, you still don't know what that means. Oh, apparently you didn't compile right. Let me make sure that I saved that. I should have saved that. Yep, you're good. It did assemble. And this has not changed. What the heck happened here? Why didn't that change? Oh, because I changed the wrong value. That's why. Let's try it now. Oh, aside from the fact that... Okay. And it's telling me it's in compile mode. That's a lie, but... Okay, I've got two things that happened wrong here. And that shows correctly. Good. So I've got a word that will put me into compile state. The next word that I need to implement is the one that will take me out of compile state. And that will take care of that. So now the next test is going to be to see if I'm in compile state. Compile mode sets, I need a way to get, I've already set the right bracket, which will get me out of compile mode, but right bracket will not function outside within immediate mode. And right now, even though it says it's going into compile mode, the state flag isn't actually doing anything. This is my starting point. Compile mode's going to be, let's see. If we're in compile mode, there's two paths that a given word can take. It is either going to be an immediate word, in which case it will be executed, or immediate / compilable word, or it will be a interpretable word, in which case it will be compiled. So there we go, and that cleans up and goes home. Okay, so that should do it. Now I just need to define what compile comma does. Unless we change the way this will be appending compile code to the location of the data space pointer. So all I will be doing here is setting up the opcode, and that means that I will need, there it is, to look up my opcodes for, I believe, jump. Let's see, where's jump? There we go. Unconditional jump, or yeah, I don't know that I need to do a JS. No, I do need to do a JSR. Jump to subroutine and jump unconditionally to the specified memory address, saving the old value of the program counter on the hardware stack. Yep, and that will, yeah, okay. So I will be giving it a 16-bit address, which is fine. Object code direct 9D, extended BD, and number of bytes 3, and indexed indirect. I will be wanting the extended, so that's going to be BD. right, so that should, let's see how we're doing so far. If I've done this correctly, I should be able to go into compile mode. No. If I've done this correctly, I should be able to grab the execution token for a word. It doesn't matter which word. Go into compilation mode, run compile comma, exit compilation mode, go back into interpretation mode, and then, yeah, so let's run some tests. It's not happy at all. It doesn't like it in the slightest bit. Let's see. Why did it not like it in the slightest bit? The thing that's missing there is an RTS at the end of the thing. I think. I should see something at 620 when I do that. So let's do the make run. Yeah, all right, good. That's the compile state. So I am in compile state, that's good. And I want to do a compile comma, and I should see something show up over. And we have a JSR to CBFF. No wonder it wasn't happening. No, it wasn't happy. That CBFF is the incorrect location. What happened here? How did that happen? Oh, maybe that'll fix it. Change from B to D. So I should be able to go into compile mode. Good. Compile comma should give me at 620. We should see that over there. JSR B0CB. Good. I should be able to exit out of compile mode. We're back where we need to be. And if what do I have on stack? I have nothing on the stack right now. So if I put B0CB on the stack and execute, victory! Nice. That's okay. Good. So that's, we've got stuff in memory and it's able to execute. The next trick will be actually putting together the compile mode itself. So I already have create, which branches out there. Variable, okay, constant does that. Variable branches out to create. So on colon, I actually want to branch out to create as well. Okay, so here's the trick. Colon needs to put me into compilation state. Colon also needs to set up a, let's see, what else do I need colon to do? Colon needs to set up the compilation state. It also needs to, oh shoot. Oh, dear. I forgot about something. I'm not able to compile numbers. I need to be able to compile numbers. I need to have that be a compilation. So if we're not here, we're in interpretation mode. So I need to look at my numbers again, because that's going to be. Now, what literal does, he says, turning on the overlay, and let's go to search. Literal appends, literal places the value X on the stack. It takes this value from the stack and places it on the stack. So if I'm in compilation mode, by default, what this thing will do is it will drop here. Also, I'll need to test to see if we're in compile state. Should be that easy. Now I just need to put literal together. No, that's not right. That's not right at all. I don't need to do that yet. That should do it. Oh, it's not happy. We load D with 001. That compiles correctly. I'll bet you, Nikolai, I forgot to do a read RTS, didn't I? Load D 3688. Yep, and push UD. Yep, that's exactly what happened. I forgot to do an RTS. And a compile, load D0001, push UD. Lovely. So let's get out of that, back in immediate mode. Let's put the one on the stack, and if I take literal, it doesn't like it, and the stack is clear. If I go back into... Nope, not that. There we go. Compile. And type in literal. What just happened? Did I not store that back in? I think I didn't store it back in. I sure as heck didn't. Beautiful. Absolutely beautiful. That's doing exactly what I expected it to do. Good. So that part is done. I can do a literal. It's all compiling the way that I want it to compile. The next trick will be to set up the opening and closing of compile mode such that we run the create. All right. The colon is what starts our definition. Place name delimited by parse name delimited by space, create a definition for name called a colon definition, enter the compilation state and start the current definition, producing a colon sys, append the initiation semantics given below to the current definition. Okay, so the question is, what is this, let's see. Yes, semicolon will consume the colon sys as an address at which to place the new dictionary. Okay, there we go. So colon. Now, nothing needs to be on the stack for this to begin. The first thing I want to do is call create. Create will place that. No. Because I need to be able to undo this in case of an error condition. I need a couple of locations here. So that's my compile state. Compile state flag mirror cell. Let's see. I need... What the compile marker data will do is hold on to the dictionary, the top of the dictionary that we had before, as well as the data space pointer that we had before. That should handle colon. Now, semicolon is going to have to close this out. That should do it. That really should do it. Let's see if it did it.
Next level.
And in this case, if that worked correctly, I should see down here, there should basically be zeros. I've got the zeros, which is correct. And if I hit colon, all right, there's nothing left to read. But what if I do colon foo? It gives me an OK. Why did it give me an OK? Did I not set this into compile mode? I didn't set this into compile mode. All right, let's fix that. I did all this work, and I didn't put it into compile mode. So I've already seen that. Let's make sure that that didn't break. It did not break. Foo does not exist. Good. I'm in compile mode. Lovely. So I should see. There's my so there's my codes. It's there at 620, which is not where I want that to start looking. I want that to start looking. So B00083 06 OF OF, and that would be 626. So I want to start that decompile at 626. Yep. Load D62C, push UD, RTS. And here, where is here? Let me look at my... You're at 235. So 235 shows me as being 0626. 0626. Okay, good. We're in compile mode. Everything looks good. So if I put a 2, 4, and times, it worked. I got a load D2, I got a load D4, I've got a JSR to B647, B647 is star. As we can see here, it is star, that looks good. And if I hit semicolon, bang, a flippin' rang. So now, what happens when I type words? Foo is there. What does foo do? It clears the screen. Well, it would make sense that it clears the screen considering there's not an RTS there. Did I forget to tell it to put an RTS in there? I thought I told it to put an RTS in there. Semicolon should... It should have. Well, I guess I'm going to have to trace semicolon now. That LBSR is to ASCII. Do I have something on the stack? I should have something on the stack. Where's my user stack? There we go. And U is at 7FFE. I've got 0620, which is the location of that, and it should consume it once it does that. So if I F10, all right, LAU2 coming to use, that should clear my stack. F11. Yep, we're fine there. We load, oh. Right. That's my problem. Let's fix that. Again, in direction, in a peach. So Q will come back over here, and instead of storing that at the memory location, which is DS pointer, we will store that at the memory location pointed to by DS pointer. And we'll try this again. Now it should work. I'm not going to bother with setting the breakpoint this time because it just simply should work. Whoop, no, F5, there we go. And if I do a colon foo 24 star, it compiled and I see colon, I see the 24 and I see the star. And if I semicolon at this point, it okays, and there's my RTS. If I type words, it's in there, foo is in there. Let's try this again. Let's see if foo works. Foo should give me something on the stack. It should do 2 times 4. U is now at 7FFE. There's something on the stack. According to memory, I've got an 8 there, and if I hit dot, I get an 8. I think I've got compile mode working. Yes. Right, that was great. We've got compile mode working now. Now, it's very simple. I don't have any conditionals. I don't have any control flow, anything like that. But I can compile custom words. They show up. They're executable. They'll run properly. There are a few little things that I want to make sure that I can do, such as setting a word as being immediate, which means that it only functions in compile mode. But that's something for later me to deal with, along with later me dealing with the conditionals and dealing with flow control. Coming up next in the Forth saga. But for right now, we've got functioning compile mode, and I'm really happy. Thank you so much for joining me right here on The Break Key. Be sure to like, share, and subscribe. And if you want to help support my crazy ventures out into the world of, vintage computing festivals, feel free to check the links below to see how you can support The Break Key, and maybe I'll see you in person at one of these fests. Have a great day.